Everyone. Today let's go over a medium question. This one is called angle between hands of a clock. Please note that I struggled with this for like a while, for like months. I don't know why, but I couldn't do it until today, so let's go over it. Basically, what I did was I sketched it out on paper and I did the calculations and it made everything more clear. So let's read the problem. So you're given two numbers, hours and minutes, and you want to return the smaller angle in degrees formed between the hour and the minute hand. Answers within 10 to the power of -5, the actual value be accepted as correct. That's not really relevant, but what we want to do here is calculate the angle between the hour and the minute hand and see which one's bigger, whatever's left over and whatever's we have right now. So first of all, we know that a full circle is 360 degrees. So that's going to help us in our final conversion. And then we also know that there are 12 hours in a clock. So let's call this H and let's divide by 12. And we also know that there's 60 minutes in an hour. So let's call this minutes divided by 60. And let's print H and M to see. We don't want to divide by 12. It's actually modulo 12 because we want to get, if it's over 12, then we want to start over from 12. So let's do this just to see the test cases. So you got 0, and then you got, so if you look at the picture, we have 0 hours, and then we still have to add whatever difference the minute hand made up for in terms of 1/12 of the clock. So this should not show up as 0. Or you know what, that's fine. That's fine. Because, so this is 3 hours, right? So 3 is here, and then 3 hours too. And then the hour here is taken up 0.25 because 0.25 is the minute hand. The longer hand is the minute hand, right? 0.25, 1, 2, 3, 4. So 0.25 is like what? 3 hours? Because there's 12 hours in a clock. So, cool. So now what we want to do is calculate the percentage, and this is where it gets a bit tricky, but let's think about this for a second. So you know that the minute hand is gonna move the hour hand by a little bit, right? So let's call this addition. And we also know that the minute hand can't move the hour hand by more than 1/12. So it's going to be 1/12 times however much progress the minute hand made. So let's put addition here. So we made 0.4% progress because 0.5, which is this 0.5 times, 0.5 divided by 60, first of all, is 5. And then we made 2.5 minutes of progress here with the hour hand. 2.5 minutes of progress divided by, I think, 60, right? If I'm correct. 5 divided by 60 is 0.41 because that's how much percentage of the entire clock with the hour hand that we need to move forward. So let's call this hours angle and let's call this minutes angle. Hours angle equals to H plus addition, and minutes angle is just M divided by 60. Let's print this out. Nope, that's not right. The minutes angle is just minutes, I think. So 0.5, yep. 0.4%, yep. Okay. So now we have our hours and our minutes. Now we need to calculate the degrees between 360, right? So let's call this hours R as for radian. So hours R equals to hours angle divided by 360. And then minutes radian equals to minutes angle divided by 360. Let's print this out. Okay, that's not correct. It's maybe modulo. No. Okay. Hold on one second. Let's see here. So I got 0.41 and 0.5. Okay. So now let's do hours radian is actually hours angle times 360, right? We want a percentage of 360 because it can't, the whole circle can't be over 360 or else it's just like a modulus. Minutes radian equals to minutes angle times 360. Let's print hours R, minutes R. So 15 and 80, cool. Now we have our difference. As you can see, now we have our difference. Let's see, why is this not? Hours. Is it divided by 12? Okay, cool. Now, yeah, divided by 12 because we're still way too big. We still haven't divided by 12 because if this angle happens to be bigger than 12, or yeah, bigger than 12, we still have to divide it by 12 because there's only 12 hours in a clock. Cool. Now we can say our difference is going to be, now we just follow the picture on the test cases. Difference is equal to absolute value of hours right minus minutes right. And then we can just return the difference. Okay, except for this case, looks like we have an issue because the difference, let's print the difference as print 360 and let's print hours R and minutes R. Because we want to get like the closest, the smaller angle of the two. So not only difference, but it looks like here the difference minus 360 could also be smaller. So turn, let's say, the minimum of difference and the absolute value of difference minus 360. And there you go. Yep. So it's a bit of a brain twister, but you just have to think of it in terms of conversions. Because here we did modulo 12, and then here we have to divide it by 12. Because there's only 12 hours on a clock, right? So, okay, cool. Yeah, thank you for watching, and hopefully this helped, and see you in the next video.